Okay, a little bit different of a video here today. This actually should be a weird one because I'm going to hate myself for this later because I'm going to be doing some editing. I'm going to have to edit this video. This is basically going to be a two-part video. Two parts, but it's one video because lazy. Don't want to make it two things. Anywho, first half is going to be a kind of fight recap, everything that's been going on with my combat robotics that I've been getting into. Rewind a little bit. You might not be familiar. If you're not familiar enough or not, you don't follow me on Instagram or anything, you may know that I've gotten in the last year and a half, a little over a year, into combat robotics. Think Battlebots, that kind of stuff. And my first robot was a Viper kit from FingerTech, great little robot. My second one was this little 3D printed Ferryweight, which did great. Unfortunately, I don't have the parts to get it up and running for this weekend. And my other robot is this 3-pound beetle weight undercutter named Offbeat. And before anyone sits down and says, "Oh, your weapon's not safe," the weapon is safe. There's no battery in the robot. The battery's in the lipo bag over there. And it is a belt drive, and the belt is right here. The belt is not attached, so I can freely spin the weapon. It's fine. It's fine. It's not going to hurt anybody. I have a weapon lock that I will put it on there, but for this video, I had to have it off because, I mean, that's just cool to do. Anywho, before we talk about this version of Offbeat, we have to talk about how it went from, well, how it got to here. How it went from what it was to what it wasn't to what it is. And we have to start with, this is technically Offbeat number 2. This is the second iteration of Offbeat. This was the first one that saw combat, actually fought. And this one's not even all put together, it's a hollow shell. This is the first version of the undercutter known as Offbeat. This saw combat in July at Arizona Robot Rumble. We were not running this. This is our AR-500 weapon. We have a titanium one, but I didn't want to dig it out. But this is our AR-500. This is mean. It's got some gravity to it. You can see it's a asymmetric spinner here. And we used a gear drive, and it was a 4-wheel undercutter. What's nice about this design is it's invertible. I could drive upside down. You can kind of see here in the wheels, we used mag wheels. There's actually magnets embedded in these TPU wheels. And then we had a single motor here and here with a gear sticking out that meshes to drive the wheels. This is a very good drive system for this robot. Being wide with a very short wheelbase, it is very squirrely, but that's really the only way we can sit on top of our massive weapon without hitting our own wheels. So this robot, you can tell, it's seen some fights. Its first fight, I fought up against a very, very talented driver, only 6 years old, driving a D2 kit. And I managed to shred a lot of his titanium screws, but we ran into one of the main problems with Offbeat's drive system, or weapon system. Its original weapon drive was gears. And these were 2 gears we melted during testing. There was so much energy and so much speed that the gears melted and then welded together. These 2 aren't coming apart. Now, these ones weren't in that fight. The way I solved the problem with these gears melting is I would grease them up heavily before a fight. And then we had some other issues that I'll talk about in a minute. Well, almost broke apart. But during that fight with that D2 kit, you can see these larger holes here. These are the holes that line up with the holes of our weapon motor, our weapon. All right, this one is the weapon motor. This one right here is the weapon motor. This one right here is the weapon itself. There's a shaft right here that connects here, and then it sits like this. So the gears are on top. The weapon motor is on this side. This shaft goes in here, and then goes there. Well, the gear with those three bolts is what holds our weapon in. What ended up happening is the bolts pulled through these holes and this gear fell off, which meant I no longer had any way of driving the weapon. And then as soon as that D2 kit, which had a little active flipper, flipped us over, my weapon fell out. So we lost that fight, mostly because our weapon fell out. We were winning it, though, in control and aggression, because the mag wheels meant that I was just planted to that floor. Our next fight is the one that really hit hard. This robot, we found out, does not do well against horizontals. You can see all this hot glue right here. We fought against Roadkill. Yes, Roadkill. Horizontal spinner. Looks like a little tombstone. He hit right here, sliced through this, caught this nut here, or this bolt here, pulled our whole wheel off. And our wheel ended up gumming up his weapon motor, so his weapon was out. But I still had drive. I still had 3 wheels that were driving, and I still had weapon. And I continued to be aggressive, push him around, spin up my weapon, do a little bit of damage here and there, and still lost that fight. And the reason I lost that, I was actually winning that fight on aggression and control, even though he had it in damage. The reason I lost that fight is because in Arizona they have a pit that opens up after 1 minute. With 1 minute left in the fight, 1 minute left in the fight, the pit opens. And I accidentally drove into the pit. We then did 2 exhibition matches and won those, so those were good. To get back to some of the issues we had with this robot during the design phase, we use a bushing. You can kind of see it right here. In fact, I have one of the bushings right here. It's big brass or copper oil-infused bushing, and then this is the shaft. It sits in here like so. There used to not be as much play, but there still is some play. Now, I notice that there are some spiral pattern on this. The original shaft was solid and smooth, and there was so much friction in here that it was melting, and then inside this bushing, it was melting inside the bushing and then welding itself in place. Or melting and then becoming lopsided and not working properly. So we did this shaft, we call it our air shaft. And my original thought was, well, if we made this so that way it has as little surface area in contact with that bushing as possible, that would reduce friction, which would mean we could spin up faster and spin up to a higher speed and have a higher initial spin up, and would reduce friction and heat and everything. And Robert had the idea of putting this spiral pattern on there with the hope that it would pull air in and force air into that gap, kind of like a propeller almost. I don't think that really worked that way. I think it just reduced friction and we had enough space between there that the heat didn't build up as much. But this was actually a real big game changer and really made this weapon work. The original solid shaft was problematic and did not work. This shaft was a big game changer. So we decided, well, this black nylon, Robert found some white, stronger nylon, and another issue we were having. I'm getting all sidetracked. Another issue we're having. These top and bottom plates are carbon fiber. Our weapon motor was mounted right here only to the carbon fiber. Well, this carbon fiber's, here's an example of the carbon fiber, is flexible. And what was happening is the whole weapon motor, as it was spinning up, like if this is the shaft, this is the weapon motor, was doing this. It was torquing itself out of position, which would cause the gears to not mesh, and then this gear, which is the one that was on the weapon motor, would explode. So most of our fights, we only had a third of the teeth on this gear because this gear would just explode. So we had 2 solutions to that. Our first solution was to go with a belt drive, and we use these big O-rings. And the second solution was to redesign the frame so that way the 3D printed frame actually went and extended underneath the weapon motor. We changed to a smaller weapon motor, well, thinner at least, same diameter. We changed to a different weapon motor, and that thicker frame plate basically completely reduced that wobble. That motor was rock solid for all of its fights. Unfortunately, my second fight at Titanic Takedown back in November was against a horizontal spinner. And here's what's left of the front of Offbeat. You can see that we have a much stronger frame. You can see that platform for mounting the weapon motor, which worked phenomenally. The belt drive worked great. It only popped off once, But we fought a horizontal. You hit right here on this corner and shattered the entire frame. It is shattered all the way over to this side. Luckily missed this space right here is where I have all of my electronics. My motor controller, or both motor controllers, weapon controller, and receiver are all right here, and then my battery sits right here. Completely missed all of those electronics. So we were still able to function, well, electronically function, but the motors were actually even knocked out of position, and I had no drive. Part of my frame is everywhere. Robot is toast. So that was the last fight for that. But again, we learned. And it's what you do. You fight, you lose, you learn. Fight, lose, learn. Until you win. And then you still learn. And you improve. We were like, this is great. But this bushing is now the issue. It was causing so much friction that we were still getting heat issues, and we were having issues spitting up. So Robert went back to the drawing board and he redesigned. He made this front a little thicker. He changed up the geometry of the inside. Unfortunately, that's all buttoned up. I'm not going to be able to show it. I'll probably show it in the post-fight half of this video. But and something that I was pushing for was doing bearings, getting rid of this bushing. The bushing was great when we were doing the gears, but the pulley, the belt, I think was causing issues with the bit. So now we have two of these sets of bearings that sit sort of like this inside the frame. There's one at the top and there's one at the bottom. And then I have at the top, between the weapon and, it's still sticky, between the pulley up here and the weapon at the bottom, pulley up here and weapon at the bottom, I have a thrust bearing. These gears are actually, these bolts are as tight as they'll go. I have a little bit of slop right there, but that's great. That's perfect. That means that I've got a lot of free spin in that weapon. Look at that. Look at that go. No resistance. Again, as I said, the weapon can't spin up right now because I don't have the belt in, and I don't have the battery on, so it only spins when I put my hands on there. But you notice we now have these. I'm going to actually grab my other one. We now have these. We did a bunch of weight reduction, so we changed up our weapon. Here's our old weapon. It's all solid, over-engineered, overkill. Robert put these speed holes. It's still just as strong, but it's lighter. It's significantly lighter. And it also is slightly thinner. It's the same general dimensions and length, but it's thinner here and here, which is weight savings by grams. We also, the way he redesigned the frame, the main frame portion of the robot here, this part here, this white part, it is significantly lighter, which allowed us to put this metal wedge on the front. So we have some metal armor. An additional weight reduction that I'm doing, I still have my mag wheels, but I'm only putting magnets in the front two wheels. So that way the robot will want to slide the back end around. I do sacrifice some magnetic grip and traction, but I gain a weight savings. I haven't weighed the robot yet. I don't know how much it actually weighs. So just for some aesthetics, though, we also changed up to aluminum top and bottom plates. They're not as strong as the carbon fiber, but they're cheaper. And we have, this front plate's actually made of aluminum, but it's a thick aluminum. Which is going to be, if we get hit, if it gets hit, it'll be a blade of armor. It should act like a blade of armor. So yeah, that's going to be it for this. We'll do the second half of this video where I talk about how good or bad this version of Offbeat did. Robert is thinking that this may actually be a Norwalk contender. It may be a Norwalk bot, so we're like, hell yeah. So yeah, I'll catch you guys in the second half after Sin City Street Fights.